Hello guys, so welcome back to my channel Code Shiba, where I'll be posting my DSA content or Elite Code solutions each and every day. Today is day 10th of doing so, and the problem that we'll be going through today is Elite Code problem number 69, which is square root of a particular number. Okay, so let's check what the problem really is. So we just need to implement this square root function in Elite Code. Or like in any other languages there are different square root functions. So how are they internally implemented is that is what we will be looking forward to. So the input will be a certain number x, and we have to return its square root. Okay, the constraints are that x can be from 0 to 2 raised to power 31 minus 1. Okay, we cannot use any built-in exponent function or operator. Hmm. Okay, so what the problem asks us is that in input we will be given some number x. Let's take x as 16 right now. So there will be a number x 16, and our task is to find its square root. How can we find the square root of a number? What we do is 16 to, when we pair this up, 2 times 2, it results in 4, which is square root of 16. Hmm. So the very first approach to this problem is that we can have how many possible solutions for 16. Like there is only one possible solution, but let's take numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So what I'm thinking is that if we have an array like this, and we need to find the square root of a particular number, what we can definitely do is we can the first approach to this problem can be something similar to linear search kind of an approach, where we will be going through each and every element and we will go until we find the right solution. We will move towards this, and there will be a check condition for each and every element, and the check condition would be if I square of a number is exactly equals to x, that means that is the answer. And if it doesn't happen, then okay, we will not take that solution. So this is the very first approach, where we will be taking numbers where we can have a for loop from 1 to x, and within that range we can check for each and every number if it is the square root of x. Okay, so After a particular number, there is no possibility for a number to be square root of 16. Yeah, to optimize the solution, we can have our second approach to this problem, which is binary search. Since we have had our since we have had our search space, as I've shown you here, we have a search space as this array. And what we can definitely do is, we can let me make another search space. So we can have a basic structure. What we will be doing here is that we'll check if this particular mids square is exactly equals to your x. We'll check for this condition, and if it isn't, like, we will have either this condition, or we will have mid square greater than x, or we will have mid square smaller than x. We can have these three conditions. For each and every other conditions, we would have something different to do. Okay, so if a number is exactly equals to if a number is exactly equals to like if a number square is exactly equals to s, we will just return. And if a number's square is greater than x, that means that we need to take mid as a smaller number. And how can we do so? We can do so by eliminating the right half, by using this logic of binary search. We will take high here, and then we will have our little search space over here, and we will assign our mid again, right? We'll assign our mid to as 3. Okay, this is fine. Since 1 plus 7 by 2, what is 8 by 2? 4. We will not take mid as 3, but we will take mid as 4. Okay, so since our mid is here, now we can, like, if we see mid square is exactly equals to 16, that is where we will return our answer. Okay, uh, so this is it. We will be using binary search to solve this problem. And since we are using binary search, the time complexity of this problem would be, we go of log log n. And in earlier videos I've told you it's log n because we are breaking down the array into halves again and again and again. Okay, and the space complexity of this problem here is like, we're taking an array of elements, right? But we aren't necessarily gonna take a vector. Instead of that, we will just be using these 3 pointers. So I think the space complexity is near about constant. There is nothing that we are using except these all pointers. And yes, since our constraints are like x is smaller than or equal to 0, so x can also be equal to 0, we will have to make an edge case where we are returning some value in it, and if it's 1, we are just gonna return that number itself. Yeah, so let's directly jump into the implementation of this problem and see how it works. If x is exactly equals to 1, what we are gonna do is we will return that particular number. if x is exactly equals to 0, we're gonna return 0. Okay, now we're gonna initialize. Now we'll be initializing our values. Int low equals 1, int high equals x. We are gonna have a for loop here. Low should more than equal to high. Not equals low plus high plus 1. Case 1, if mid times mid is exactly equals to, that's why I don't really like windows, but now, so mid square is, if it is exactly equals to x, we need to return mid. This value is smaller than 0. What we will be doing is smaller than, not x, if a value is smaller than x, if something's value like 8 square 64, which is greater than 16, or if a value like 3 square which is 9 and it is smaller than our x, then what we will be doing, we will be taking our low and we will be going forward here at m plus 1. Will word search space like this, and else if this for loop doesn't return a value, we will have a dummy return statement. I think we need to take long we will always have an answer, right? We'll always have an answer. So this dummy statement, we can return 0 over here. Let's see if it works. Okay, so for some conditions not working. 0 is Let me take some different number as x, so this is 25, right? We can have 1 as the starting point, and then we will have our mid as 26 by 2, 13. 13 square is obviously greater than 25, so we'll have our high updated to 12, right? So now our search space is between 1 to 12. 8. The x here was 8. If x is 8, then 1 to 8, and our mid would be 9 by 2, which is 4.5. We will take its floor value, so it will be 4. So mid will be our 4. 4 squares 18. 4 square 8. We can even have a answer, and every time when this case hits, we can update our answer to so now it's working, because either of the pointers will return as a result, and when this case 2 hits, like when square of a particular number is smaller than x, that means we will be this particular value here after mid can be one of our solutions. And yep, this is it. Let me submit this problem and see if it works for large test cases too. And yes, it works, and it is the most optimal solution. So thank you guys for watching my video, and thank you for supporting me. Let's grow together, guys. Okay, bye.